Okay, we are on 2017 FRQ number 3 on the non-calculus section. So we're going to start with the function f is differentiable on the closed interval between -6 to 5 and satisfies f of -2 to 7. The graph of f prime, the derivative of f, consists of a semicircle and 3 line segments as shown in the figure above. So this first initial condition given to us allows us to write the relationship of this function. So it allows us to define f. F is equal to the initial condition, the initial y value given to you, and then along with the integral, starting at this value, you want -2 to x of f prime. So that if you're looking at f prime, you're just looking at the graph. And if you're looking at f double prime, you're looking at the slope of the graph. Okay, so with this relationship outlined, it should be very easy to figure out what it's asking you in the following sections. So part A says, find the value of f of -6 and f of 5. So for part A, f of -6, we plug it into our formula, 7 plus the integral of -2 to -6 f prime. Now remember, that is backwards because you really want to go from small to big. So in order to do that, we're going to switch it and make it negative. So -6 to -2 f prime. All right, so 7 minus, what is the area from -6 to -2? Well, that's this region right here. It is a semicircle. That is 1/2 base times height. So that's the area of 4. So 7 minus 4 gives me a value of 3. So f of -6 is equal to 3. Okay? All right. F of 5. So f of 5 is equal to 7 plus integral -2 to 5 f prime. Okay, so in this picture, f of -2, -2 is here, -2 all the way to 5. So that's our semicircle and our triangle here. So semicircle is going to be 1/2 pi r squared. So that's 2 pi, negative because it's below the x-axis. So -2 pi. This triangle is 1/2 base times height. So that's 3. So then, since this is the right order, we don't need to worry about changing the integral here. So it'd be 7 plus parentheses, the area of -2 pi plus 3. So if you add it all up, that's 10 minus 2 pi is this value for f of 5. Okay. So part B, on what interval is f increasing? So if we take a look at our graph again, let me clean some things up here. Where is f increasing? So you ask yourself, how do I know it's increasing? That is when f prime is greater than 0, right? F is increasing when the first derivative is greater than 0. Since this graph is our f prime graph, it is when the graph itself is above the x-axis. That's when it's greater than 0. So where is it above the x-axis? It's above the x-axis here and above the x-axis here. So in the interval of -6 to -2 and from 2 to 5. So those are the intervals that the f is increasing. Okay, beautiful. All right. Find the absolute minimum value of f on a closed interval -6 to 5. Justify your answer. So remember, to get an absolute minimum, your slope has to go from decreasing to increasing. So my slope has to change from negative to positive. Right? Minimum is decreasing to increasing. So change from negative to positive. So my graph has to go from below the x-axis to above the x-axis, right? So here is where x equals 0, slope is 0, slope is 0. But which one of these went from negative to positive? Only here at 2, because that graph went from negative below the x-axis to positive above the x-axis. So that is a minimum. Now, is it an absolute minimum? I don't know. So I have to check against my closed interval. But I'm going to check that value first. So that value is 2. So f of 2 is equal to 7 plus integral -2 to 2 of f prime. All right, I'm going to have to use some space down here. Okay. All right. So let's see. I am on C. I'm going to check f of 2. That's 7 plus integral of -2 to 2 f prime. So 7 plus from -2 to 2. So -2 to +2 here. That's our semicircle. And we discussed that that was -2 pi. So plus -2 pi. So 7 minus 2 pi. So my endpoints are -6 and 5. So we have those two values from part A, right? So we knew that f of -6 was 3. F of 5 was 10 minus 2 pi. So is this truly a minimum? Well, I know 7 minus 2 pi must be smaller than 10 minus 2 pi. So already I know that's smaller. Now I just got to check it against 3 because I don't know if that is truly smaller than 3. If it's truly smaller than those two, then this is truly an absolute minimum because this is a closed interval. That's the lowest point, right? So again, you got to use a little bit of estimation. You can do approximation and say, all right, pi is about 3.14. So 2 pi is about 6.28, right? So 7 minus 6.28 is about 0.72. That's definitely less than 3. So for sure, this is a true absolute minimum. So absolute minimum at x equals 2. And you already justify your answer because you truly show that this was smaller than these two, and the fact that the slope, so f prime, changed from negative to positive. All right, so you got to show that your slope did change, and that's how you knew that this is a minimum. Okay. All right, part D. For each f double prime of -5 and f prime double prime of 3, find the value or explain why it does not exist. So we're looking for f double prime of -5 and f double prime of 3. So f double prime, if we look at this, it says it's really looking at the slope of the graph. So we're looking at the slope at -5. So let's take a look at -5. X value of -5 is right here. Since it's a linear graph, it's very easy to see. We can just look at the slope of, okay, down 2, right 1, 2, 3, 4. So that's down 2, right 4, -1/2 for the slope for the second derivative at -1/2. What about 3? So 3 is right here, right? And you can see this is a corner because the slope before it was going up, it's positive, and the slope right after is negative, and there's no switching. So you cannot find the slope. So you have two ways of describing this. You can say, first of all, the slope does not exist because it is a corner. Or you can be very specific and say, all right, well, the limit as x approaches 3 from the left side of the second derivative, on the left side, the second derivative is a positive 2. If you look at your graph, you can see it's up to right 1, right? And then on the right-hand side, from the positive side, f double prime, that slope is actually -1. If you look at the right here, you see down 1, right 1, down 1, right 1. So they are not the same. They're not equal, right? So because they're not the same and there's no gradual change to these two derivatives, these two slopes, therefore the slope does not exist at this point. Okay, all right, that's it for this problem.